In this video, I'll talk to you about SAS programming. SAS programs are constructed from two basic blocks: data steps and proc steps. Data steps read and modify data, while proc steps analyze, sort, perform function, print, and etc. Each step contains statements end with semicolons. Though several procs are going to be introduced, the proc IML is one of the most important procs in the purpose of this course. In an IML program, all the variables are matrices, and you don't need to specify the type of a variable. Let's look at an example using the proc IML. So this is the data step. The name iris is the name of the SAS dataset. The data is read from a text file using the in-file statement. DLM specifies the delimiter in the text file, and the input statement names the variables in the dataset. So here we have h1, h2, h3, and h4. And run is the last sentence in the data step, and then comes proc IML. The first statement is use iris. So iris is the data set in the data step previously mentioned here, and use iris open the data set for reading. The next statement read all the observations, and here we have a set of selected variables to be read into X, and then compute the covariance of X and print it out. Before going into the detail with proc IML, we get through several parts. First, we talk about getting data into SAS. Let's first look at the example when the data is from the direct input and the data are separated by spaces. So in this data step, we create a data set, namely US presidents, and then the input statement specifies the name of the variables in the data set. So the first variable is president, and it is a character type. So after the name of the variable and also a space, you have the $sign. So this says this variable is character type. So as the second variable, and finally comes the last variable. The statement data lines signals the start of the starting point of the data block. So each observation is on one line, and each value in the same observation are separated by a space. And the semicolon that follow after the data block is to signal the end of the data block. And then run is the optional last statement in the data step and proc step when you use the batch processing for SAS program. And a batch processing means that when you write the whole program, and then submit it to SAS to run. And then after the data step, you have the proc print. In the proc print, you specify data. The data here you specify the data set, US presidents, and also the run statement, the optional statement. And this proc will print the data set, and this is the result when you see in SAS. With the same example, You can also read from an external file. So in file, you specify the path to the external file. The rest of the code can be the same, and in here you have an additional statement to specify the title of the print, and this is the result. So when the data are separated by spaces, then we say data are read using list input. This is another example, and we read data from total jump .dat, and between data between fields or variables, we have spaces. And the missing data are actually just the period. And there are some restrictions. If you have character data, then it must be less than or equal to 8 characters and contains no space. And the values are separated by this one space. Otherwise, you don't know how to separate the data. And the missing data here, the period. So in the data step, very similarly, in the in-file statement, you specify the path and also the file name. And then the input statement defines the variables. The rest of the code is the same as the previous example. The block print just for printing the data. And this is the result, the content of the file and the printout. If the data are arranged in columns, then you will read using column input. So this is an example in this file, onionring.dat. In each observation, the first variable is a sort of character, and the second, the third, etc. In the third observation, you see there is no space between the value in the second and the third variable. So you cannot read this using the list input. The advantage of using column input is space is not required, and the character data can have space like this. You can have space here, and the missing values can be blank. Don't have to be a period. And this is an example. We just need to look at this. In the input statement, you have the name of the variables. So this is the name of the first variable, and the type, which is a character, and also is specified the width. The width is from 1 to 20. So it specifies the column, and it reads the whole column from 1 to 20. And you see the same format in the other variables. So concession sales, you have the data starting from the position 21 to 24, and with bleacher sale, it starts from the position 25 to 28, etc. And this is the result. So you can see it can read data effectively. So you can see here there is no space between 15 in the second variable and 1000 35 in the third variable, but because you specify the width of the column, so you can still read 15 in concession sales and 1035 in bleacher sales. And also it's blank here, so it is considered as like missing data, and you have missing data in the second observation with bleacher sales. Next, let's talk about working with data. How we create and redefine variables. In this example, in the data step, we create a SAS dataset home garden, and the data is from a dat file with 1, 2, 3, 4, and 5 variables. Then later on you define a zone variable. This is a new variable, and store 14 to it, and another variable, namely type, and store a string home to it, and then another variable Yoshini, which actually the variable that you read and multiplied by 10 and override itself. So basically you will see the values are like 10 times larger than the original values. And then you also create another new variable, namely total, which is a total of 4 variables. And also per tomato, this is also a new variable. And then later on you print everything, and this is the result. You can see we have 4 more new variables. In this example, we will talk about how to use if-then statements to subset data. So in the data step, we create the data set old cars, and the data is read from auction.dat, and the input statements specify a number of variables using column input. You specify the width of the column, and the first 2 variables are of character type. So if year made is less than 1890, then veteran is yes. So there is no veteran in the original list of variables. So you create a new variable and store yes to it. In another if statement, if model is this, then you change make to Oldsmobile and seats to 2. So why is that? We will look at the data and see. And finally, you just print the data set. So in this example, we have used if-then structure to create new variables or change existing variables, and this is the result. In the data set, you can see the make is blank or missing for this model, and also the number of seat is also missing. So in the second if-then structure, we replace the missing data, and here you see that is the new value for the make and new value for the number of seats. If then else is also used for grouping observations. So in this example, you have data from home.dat and their owner, discussion, and cost. In the if statement, if cost is missing, then the cost group is missing, so we use cost group is a new variable that group the observations. And if the cost is less than 2000, then we assign cost group to low. And if cost is less than 10,000, then we assign cost group to medium, and else cost group is assigned to high. And let's look at the output. So this is output, and cost group is a new variable, and that we have used for grouping observations into low, medium, and high, and also missing. Now talk about using if for subsetting data. This is when we use sum and exclude the rest of observations. So here we create a data set comedy that gets data from Shakespeare.dat, and there are 3 variables. And here we say if type is equal to comedy. So this means that only observations with type equal to comedy are included and excluded otherwise. And later on we print comedy with the title, this title. And as you can see in the result, there are only 3 observations, and they are all with type comedy. Observations with different values in this type are excluded. So they are excluded. And he is also excluded. You can use arrays in data steps to write code and that makes the code more efficient. So if you want to apply some operations to a number of variables, then maybe it's a good idea to use an array and loop through an array and repeat those operations. In this example, we create a data set, namely songs, and the data is from this file. And there are a number of variables such as city, age, and there are other 5 variables. So if we want to apply some operation to those 5 variables, then maybe it's a good idea to specify an array. And let's say we name the array song with 5 elements, and we specify the variables that make up the array. And later on we should loop through the array. So instead of writing some code for 5 different variables, here we use an array and loop through an array. And in each iteration we have an if. We say if the ith element of the array song is equal to 9, then we store the period into that element. So instead of writing 5 rows like this, we just need to write a loop, and we loop through all the elements in the array. Next, we talked about sorting, printing, and summarizing. In this example, the data step reads the data, and then later on in the proc step, in proc print, we specify which observations are going to be printed. So only observations that satisfy the condition, this condition, is going to be processed by this proc. And this is the result. First, this is the data set, and you can see there are 7 observations. The variables genre contains values such as impressionism, post-impressionism. So only observations that have impressionism in genre are going to print it, and there are 4 of them. Proc sort can be used to sort the data. So in this example, we have a data set, namely marine, and then we can sort the data using the proc sort. In the proc sort, we specify which data set to be sorted, and that is specified using the option data. Another option which is out to specify the output data set, which is sorted by family in descending order, descending order of length. So if you have, you may have more than one fields after the by keyword, and the data is sorted in the ascending order of the fields, but with the descending order of other fields listed here. So in the result, we can see so the order of observations looking at family, then we can see start with shark and then whale. So it is ascending order, right, from S to W, but with the same value in family, then the observations are sorted in the descending order of length. So it goes from 40 to 30, 12, and 0.5. Now we talked about summarizing data using proc means. Proc means is a good procedure to use when you are only interested in the basic descriptive statistics, and it gives you the sample size, the mean, standard deviation, and the minimum and the maximum values. In this example, the dataset sales is first sorted by month in the ascending order, and then proc means calculates the means by month for flower sales. The option data specify the dataset and by month and which variables and which title, and this is the result. In the dataset you have 2 months, right? May and July. So you have month equal to 5 and month equal to 6, and for each month you have 3 variables, right? 3 variables: sample size, mean, standard deviation, minimum, and a maximum, and also similarly here. Next, we talk about counting data using proc from freq for frequency. So in this example, we create a data set, namely orders, and then we apply the proc freq. The table's statement specifies 2 tables. The first is one-way table for the window variable, and the other is a 2-way table for window by coffee. So as a result, we can see the one-way table and the 2-way table. Next, we talked about the proc tabulate. This proc displays descriptive statistics in tabular format, adding sum of all of the variables in a dataset, and it computes many statistics computed by proc means, freq, and report. Let's look at an example. In this example, we create a dataset, namely boats, and then later in the proc tabulate we specify the dataset by the data option. The class statement specify variables to group data, and the table statement specify the page, row, and the column expressions. So this is the result, and we can see port as a page expression, locomotion as the row expression, and type as column expression. Next, we talk about output with proc report. So here we have a dataset net packs from this file. Then we run two reports, one with the whole dataset and another with some selected columns, museums and camping. And in the following slide we see the results for the two reports. In this example, we will talk about modifying a dataset using a set statement, and this is a simple example in the second data step, which create the dataset average get chain. The set statement specify the data to get from, and then a new variable is created based on people and cars, and finally the data was printed. Next, we talk about visualizing data with SAS. In this simple example, we create a data set, namely electricity, and there are two variables, time and kilowatt per hour. Then in the proc GP plot, you can plot kilowatt per hour against time. The same thing can be done using proc SG plot, and here you, instead of using the plot statement, here we use a series statement to specify X and Y, and this is the result. Next, we talk about a matrix programming language with the proc IML. First, we go through several control structures such as if, then, else. So if with the if, then, else control structure, if the expression is true, then run statement 1. Else if another expression, then run statement 2, and else run statement 3. The do loop structure has 3 variations. Do for variable from start to stop, when we know how many times we have to loop, or do while, and do until. Do while the expression is still true, and do until the expression is true. So this is an example, a simple example with proc IML, and here we have a loop for I from 1 to 5 with a step by 2, and in each iteration print the string, the value of I is, and then I. So the loop will print the value of I with a step of 2, basically 1, 3, and 5. Next, let's talk about matrices in proc IML. So in this example, we create matrix A and matrix B. A matrix is defined by the curly brackets, and this is a 2 by 2 matrix, and that is also a 2 by 2 matrix, and you use the comma here to separate between rows, and then we sum A and B and store the result in sum, and then print sum. This slide shows some other examples for matrix creation using the J function. So this example create a 10 by 1 column vector. That example create 1 by 5 row vector, and basically a row vector of 5 elements. In this example, we create a 10 by 5 matrix of 0, and in the last example we have a 3 by 2 matrix of missing values. Similar as in MATLAB, in Python and other modeling languages, SAS use the colon to create vectors of sequential values. To transpose a vector or matrix, we use the T function, and this is as similar as in R. And for changing the shape of a matrix, we use the shape function. So shape, reshape X into a new matrix of 4 rows and 3 columns. In order to extract data from matrices, we use the square brackets. So X23 means that we want to extract the value of the second row and the third column. We can also change the value of the element. We can also extract rows and columns by specifying which rows and which columns to extract. If the column is omitted, then it means that we need to take all the columns. If the row is omitted, then it means that you want to take all the rows. This is an example for element-wise matrix operations. We have A and B, and AB is the element-wise matrix multiplication of A and B. This page shows the example for matrix multiplication. So V is a 2 by 1 vector, and A is a 5 by 2 matrix, and Y is the result of the multiplication of A and B. Next, we talk about modules. A module is a set of IML statements compiled as a single program, and there are 2 types of modules: program modules, which are activated using a run name statement, and function modules, which actually return a value can be assigned to an IML matrix. A program module is defined with start and finish. After start, you have the module name and the list of arguments. The syntax for function modules is similar, except that you have a return statement that returns the result from the functions, and later on, when the function module is called, the return result is assigned to a matrix. This page shows you a simple example of a program module. So the program module is add 2 to X. This is actually 2. And later on, when you call using the run statement, call add 2 and give it A. So A was assigned to 10, and when you call add 2 with A and then print A, you get the final result of A, which is 12. And finally, this page shows you another example for a function module. The difference here is we return X from the function, and later on when we call add 2 and give it A, we get the result back from the function and store the result back to A, and then we print A and we still get 12.